Okay, we're on to part C. This is when you actually have to take the FRQ. So it says for t less than 10, we've got an alternate model. So we're introducing a new function when time is less than 10 minutes. So it's g that satisfies this differential equation, and g of t is measured in degrees Celsius, and g of 0 is 91. So find an expression for g of t. All right, so that's us finding the differential equation and solving the differential equation. And then don't forget to do this based on this model. What's the internal temperature at the potato at time t equals 3? So you're going to get a y equals equation or g equals equation, and you're going to stuck t equals 3 into it. Okay, so it's quite a lot of work, but and you can tell this is where the major points are. So let's just solve it. So we have dg, let me change to white, sorry. So we have dg dt is equal to negative of g minus 27 to the 2/3. Okay, now we're going to separate that. So we'll say 1 over g minus 27 to the 2/3 dg, or you can say g minus 27 to the negative 2/3, doesn't matter, equals, I'm keeping the negative over here, negative dt. There's me separating my variables. So then to integrate those, so let's just write it, g minus 27 to the negative 2/3 dg equals the integral of negative dt. And taking the antiderivative of those, I get g minus 27 to the 1/3 over 1/3, which is just going to be 3. So I'm going to erase that and put a 3. G minus 27 to the 1/3 equals negative t plus c. All right, so there we have our antiderivatives. Let's solve for c right now. We're going to use 0. So put at 0, 91. We have 3 times 91 minus 27. We already know that's 64 to the 1/3 equals negative t, which is just 0, plus c. So then we have 3 times 64 to the 1/3, which is 4, equals c. So if you do it here, you get c is 12. You'll see later on the hard copy one, I did it later and got 4, which both are right. It comes out in the end. But this is how I did it when I was doing the video. So that means we have 3 times the cube root of g minus 27 is equal to negative t plus 12. Okay, so let's keep solving. The cube root, let's see, we're going to do 1/3. So the cube root of g minus 27 is equal to negative 1/3 t plus 4. Is that plus or minus? I'm trying to make sure that I have it right. Oh, it's plus. And so g minus 27 equals 4 minus 1/3 t cubed, and g then equals 4 minus 1/3 t cubed plus 27. Okay, so that's what I got for G, and that's correct. But now we've got to do one more thing. We've got to go up here and find what it would be when t equals 3. So G of 3 is equal to 4 minus 1/3 times 3, so 1 cubed plus 27. So that would be 27 plus 27, which is equal to 54 degrees Celsius. Okay, so let's get our points for this. Okay, point 1 is for separation of variables, right here. We have another point for both antiderivatives together. Both antiderivatives together. So that's another point. Let me erase that so it doesn't get confused. You get another point for the constant of integration and the initial condition. So they're putting that together. The plus C and getting a C. So I'll just put +1 here for those two things. And then you get, this is worth 5 points altogether. You get 1 point for the equation and 1 point for the model, internal temperature at T is 3. So that's a total of 5 points. Okay, so that was the answer and the points for part C. Hope you did well.